Hi everyone, I hope you're doing good. My name is Pranav Kole and I'm going to talk about algebraic expressions and identities on the behalf of Tutor Here. So what are expressions? Expressions are mathematical statements that have a minimum of two terms containing numbers or variables or both connected by an operator in between. For example, x plus y is an expression where x and y are terms having an addition operator in between. There are some definitions that we have to remember. And suppose we have 4x plus 5 expression. So terms are added to form expressions. Terms themselves can be formed as the product of factors. In the above expression, the terms are 4x and 5. Factors. Simple definition of factors is something which is multiplied by something else. In the above expression, the factors are 4x and 5. And finally, coefficients. The numerical factor of a term is called coefficient. Here, coefficient of x is 4. Monomials. Expressions having just one single term is called a monomial. Example 9x, 56xy, minus 12y, 72xyz. These are all monomials. Talking about binomials, expressions having two terms is called a binomial. For example, x plus y. There are two terms in this equation. 9x plus 12z, 56xy plus 27ab, 7 minus 12y, 72xyz minus 89. All of these are binomials. Trinomials. Expressions having three terms is called a trinomial. 9x plus 10y plus 11z, 56xy plus 2z plus 2, 5 plus x minus 12y, x plus y plus z. All of these have three terms, hence they are trinomials. Looking at the big picture, what is polynomials? In general, an expression containing one or more terms with non-zero coefficient is called a polynomial. A polynomial may contain any number of terms, one or more than one. Basically, monomial, binomial, and trinomial, all of these are parts of polynomial, like and unlike terms. 7x, 14x, and minus 19x are like terms. Similarly, 12x square, minus 9x square, 19x square are like terms. 7xy, 9xy, minus 8xy, all of these are like terms. But 8x and 8y are unlike terms. 9x and 9xy are unlike terms. Even 5x and 6x square are unlike terms. Do you know why this is? Because to find out whether the term is unlike or like, what we have to do is look at the we do not have to look at the coefficient, we have to look at the variable part. Here, as you can see in the like terms, the variables are same, just the coefficient is different. But when you talk about unlike terms, the coefficient is the same, or it may not be same, doesn't matter, but the variables are also different. Like 8x and 8y. The variables here are x and y. Addition of algebraic expressions. Suppose we have to add three equations as you can see on your screen. How we can do this is, we have to, okay, now that we have learned the like term concept, what we have to do is we have to bring the like terms together in a single column. Like as you can see, 7xy and minus 2xy are similar. Hence, they are brought down to a single column. Similarly, 5yz and 4yz are similar. Hence, they have an individual column. Minus 3zx, 9zx and minus 3zx are similar. And so on. Therefore, and then we can perform addition. Basic concept here is if the variables are same, then we can perform addition, subtraction, multiplication, or any kind of thing with the coefficients. Therefore, 7 minus 2 is 5xy, 5 plus 4 is 9yz, minus 3 plus minus 3 plus 9zx is 3zx, and plus 5x minus 4y. This is because there are no like terms available for x and y. Subtraction. The same method we have to apply for subtraction, where we have to get the like terms together as we have done on the screen. But here, the catch is that when you're subtracting the second equation, which is written by you, it can be any equation, all the signs of the terms will be changed. Like 5xz becomes minus 5xz. Minus 4yz becomes plus 4yz. And so on and so forth. Therefore, here 7 minus 5 is 2xz. 4xy has no similar terms, therefore it comes down as it is, and so on and so forth. We'll get the result. Now, let's look at the multiplication part. Suppose we have to multiply two monomials. Here, what we can do is what we have to do, in fact, is we have to take the coefficients together and we have to take the variables together. As you can see in the first example, what I've done is I have clubbed 5 and 3 together and x and y together. This becomes 5 into 3, 15, and x into y, xy. Therefore, it becomes 15xy. Similarly, if we have 5x into minus 3y, but we have to follow the same rule where we combined 5 and minus 3 and multiplied it, getting minus 15, and then x and y giving us xy. In the third one, okay, we have done the same thing in the third one. As you can see, 5 into minus 4 is minus 20. And since there is x in both the terms, we have multiplied it twice, giving us x squared by z. Multiplying 3 or more monomials. Here, while multiplying 3 or more monomials, what we can do is there are 3 methods. We can see it through the example. In the first method, what we can do is we can multiply the first two terms and then multiply the result with the third term. As I have done in the first example, I have multiplied 2x and 5y, and then later I have multiplied it with 7z. Second method, what we can do is we can, again, following the addition and subtraction method, sorry, not addition, subtraction, multiplication method, what we can do is we can club the coefficients together and the variables together. And that's what I've done in the second example. In the third example, what we can do is we can find out the similar terms and then multiply it with each other, giving us the most simpler way of approaching it. Like if I had followed the previous method where I had multiplied two terms and then further multiplied it with the third term, it would have been a little hectic and tedious work. But as you can see, I have spotted that there are 3 m's, 3 n's, and 3 p's. Therefore, it becomes m cube, n cube, p cube. So I know it's a bit of a tough topic. So if you have any doubt, you can just ping me on the comment section and I'll answer it. And thank you for watching. It was really nice. And I'll see you in the next video.